I don't really know very much about this kind of thing, but I'm curious about the actual process of testing. How did you go about getting these numbers? Like, how did you collate this information? Did you grind the coffee, or like, how did you assess it? Does that make sense?
So that's
Sorry?
what did UK do to the samples, basically?
So that's the question on the little experiment that we presented.
Yeah.
Okay. Yeah, we did not show any of the experimental details, but I think and Lina is not here either. We grounded the coffee. We made a standard brew. I have the details on my computer if you want. I can't remember them. And then from that we did a so-called dynamic headspace collection, where we have a flask where we put in the coffee, and then we close it, and then we have a vent on one side where we put a trap where we have a little absorbent material, and then on the other side we just blow nitrogen over the sample, and we do that for I think about 20 minutes, and then the volatiles, they are sort of swiped off from the coffee through this vent, and they are actually trapped onto this trap because it's an absorbent material that is likes to bind, well, in a weak sense, bind these volatiles. And then we take this trap, and then we bring it into a desorption system that's linked to a gas chromatograph mass spectrometer. And then all these volatiles that are collected on the trap, they are separated into the GC. And then for each component we get a spectrum, and we identify the components individually. So we get sort of over time all kind of peaks that we all identify. And that's what we did with this little test for the two kinds of roast. And Morten, he made different roasting. So we actually run this analysis. Was it 3 or 4 replicates we had?
Yeah, 3 replicates.
Yeah, 3 replicates.
Yeah.
So the data that I showed you is the average over 3 replicates.
Is there a big difference between all 3?
No, because the components I showed you today, they were, because we identified 54 components into these coffees. The components I showed today, they were the ones that were significantly different between the roasting with nitrogen and the roasting with air. So there was some difference, but as I said, I'm not too proud of it yet because it's such a small study, and it's only one thing. I would like to see that repeated again. That it's really because we had that was a week ago. We had a long discussion about this, but how can we explain this? What's really happening here? Because normally, I mean, to me, it seems to. I cannot fit it with any of the theories that. So it's still a puzzle.
Yeah. So the chemical analysis is a purely technical analysis. So aroma. Sorry. Oh, sorry. Yeah. It's a purely chemical analysis, and you could hear it's technical. It's nothing but technical. So it's separating and identifying the aromatic compounds. So sensory science is something completely different. In the sense, sensory science is using people to gather sense impressions and do statistical analysis on what people report, where aroma chemistry is taking the substance and then do a pure chemical analysis. Of course, you've got some ideas of when you've separated and identified, you have an idea of how it tastes, but there's a lot of things with thresholds and context and things that you need to make a full analysis. You also need to have a sensory analysis to see what would people report if they tasted this. And we only did the chemical here because that was our first pre-project thing we've came up with.
Yeah, because in the system that you have developed, you just blow through the air.
Yes.
And that's what puzzling me, because in this other system we have here, in the lowering system, it's a closed system.
Yes.
So there effectively you maintain the moisture into the system, and that I can see, okay, that will probably give a milder roasting conditions. Whereas in this system, you also sweeping off the water, that's why I'm a bit puzzled here.
But we wanted. I mean, we had two hypotheses regarding the smart roast, and that the one was, what does oxygen? Two questions: what does the oxygen mean, and what does the humidity mean? And we just decided to test one of the things. So you can say my system more looked like a traditional roaster where the moisture is removed all the time. So here only the oxygen is different. So I think it's good with model system to test only one thing at a time. So we did with the oxygen, then we can make another model system where we test have the same oxygen level but test different humidities. So it was separating out one of the two things we were interested in. And I think it's from the things we have had present, it was pretty successful. Yet it's completely brutally simple from what we would like to do.
I think I have a question here.
I'm not sure how to ask this question, but you talked about bread, and when I bake bread, I always think about how water travels within the bread, because my idea is that water, without the water and without the traveling of water inside, like the bean or in the bread, you don't have the reactions that you want. So I always think about when you roast on Loring, you have a slower transportation of water and you have a slower transportation of heat as well. But how can you test that one? Because I know there's more humidity in the chamber, but what goes on inside the bean? Do we have free passage for the water inside the bean and all that? And how does,
I think what one could do is to actually develop a model system where you can actually take the bean into a system where you can actually put a thermocouple on the bean, so you can actually look at the temperature profiles, for instance, which is also an indication of the transport of water. I think you can actually develop a model system where you can actually start studying the effects on the bean at the bean level, and I think then you can get some more information on what is important and what's not. And we have been discussing this as well, that maybe we should develop some systems like that as well.
We will.
Yeah. So maybe that gives some answer to your question, how you can study this. Yes, I think you can do this at the bean level. I know the group in Zurich in Switzerland, they have developed this model system as well. Some 10 years ago, I think, or 15 years ago, they were doing these kind of model studies on beans, and when it really successfully could actually monitor the roasting process at the bean level by just putting sensors on the bean, and then afterwards analyzing the different products that were formed during this roasting.
All right, we've got any more questions on, especially the Mayana, Joanna?
Yeah, especially about the Maillard. You were saying, like, if we have the oxygen, it can impact the moist level, and then we can have like a longer Maillard reaction. To me, it's always been like, okay, that's a reaction that happens on a certain degree, and bindings and the breakings will happen. I mean, what does time really matter to that? Like to have a longer Maillard reaction?
Yeah, I don't know, but with the bean, I mean, if you start heating up the bean, at some point it will puff, I think. Yeah, so you have the lead time to that process. I think that's already something that is at least one thing that you can vary. I think you can, by reducing temperature, you will probably prolong the time before the puff, and that will have some impact already at that stage, I think. And so in that way, I think, I mean, it's always in Maillard reaction, I think, well, it's the four most important variables is always the moisture content, and especially when you go below 20% in a product, then Maillard reactions to restart accelerate. It's the temperature time combination. It's always a combination of temperature time, because if you have a lower temperature, then it takes a longer time for several of these reactions to occur. That's just in any chemical reaction the case, and then it's the pH, which is a more important factor. And yeah, but I'm not a coffee roaster expert, So maybe that question should be discussed with some of the roasters here, people that have much more experience from the coffee roasting. We are just coming a little bit into this area. We have had some master students working with some coffee roasters, and so we are also learning along the way. So,
can I ask one more thing about the pH level? It's also a bit about the roasting, but I've been thinking about it lately. Like if you measure the pH level of the roasting, I mean, of course, they will all have different depending on what they have from the very beginning. But just like to see color or sugar level, or do you think that can be interesting to level the pH level after roasting?
to change the pH after roasting. Is that what you're
No, to mainly like measure the pH level depending on how you roast.
Yes, you can measure that. I was thinking more with pH. I don't know, but I was just discussing with a colleague down there to say, like, you have the fermentation of the beans, and is there anything in the fermentation that you can do, or is it just also anything before entering the beans into the roaster? Is there anything there that pH could be a factor to manipulate roasting? But that is just only a line of thought at the moment. But I think in the fermentation there you get some acids formed, and so you get some change in pH that could be impacting something on the flavor formation, I think.
Yeah, but since you will have, since you will have, I mean, you can roast some acids away, and you will have different like intensity of the acidity.
Yeah.
And as a roaster, I mean, that could help me as a tool to actually see the intensity of the acids.
Okay. Yeah. Yeah, I take that point. Yes, that's true. So yes, you're right. I think you can on the pH level. That could be maybe a simple way of getting some idea of this release of the acid.
Yeah, so your question is, could the pH be measured as some kind of indicator of what has happened?
Exactly.
Like you measure the, for example, moisture level and roast degree.
Yeah.
If pH would also, and that would be up to us to make some model system to make this useful, because of course you can measure it, but the question is, what does it say about the roast degree or the roast taste and flavor? And it's, I'm sure it's very, very complicated, but we might be able to do some model systems that could put some light on a relationship. If, let's say, you have both organic roast loss noted, roast degree, and then pH. Perhaps the pH could say something extra about the roast as such. But so it might be, but it would take a lot of research before we could find out whether that could be an interesting indicator for the roast master to also log afterwards.
Yeah, we already use the moisture sort of as an indicator before we roast and then after to see, did we go too fast, too slow, whatever. So pH could be, could there be any other things that we could measure sort of without having a mass spectrometer? That could give indication.
I'm thinking about things like physical properties, the swelling of the bean.
Yes.
And so that there's a lot of things. The question is always, what does it tell us anything about? So we would have to do a lot of studies to see, because I really want to also look at the physical parameters. Could be something with just the swelling, but we could also do something about the internal the pores formed, the shape or size of those, or something like that. But